Hello and good day everyone. We are Group G from Section 21 for subject SSCE2193. Today, we will present our project. Before that, meet our group mate, which is the first one is Afika, Wei Ling, Guan Xian and Iqbal. For the introduction, in this presentation, we will present the result of our group project on the status of production of Group G. To make this miniature, we analyze the data and perform several tests to determine whether the tablet production is performing as expected. There are three parameters to determining the quality of the tablet produced, which are weight, relative density, and tensile strength. There are four parts for this presentation, which is part A, part B, part C, and part D. I will explain for the part A, which is describing and summarize the sample data. For part A, we need to describe and summarize the sample data of our assigned lajak laku tablet, which is lajak laku tablet G, produced in December 2021. Then present the observation effectively in numerical, tabular, and graphical forms. For the first parameter, which is weight of tablet, these are the numerical form, which and the summary of the weight. And then we forming the tabular and graphical view. For the tabular form, we have the classes which with interval of 10. And next is for the second parameter, which is relative density of the tablets. First, we form the numerical form, and then we form the tabular and graphical view, which with the class interval 1. And the last one is the tensile strength of the tablet, which is the third parameter. First, we form the numerical of relative density, and then we form the tabular and the graphical view, which with the 1.0 class interval.
Okay, so now we get into the part B, which we need to presenting the analysis and comment whether the lajak laku table follow the distribution. In part B, we are given the question that the Food and Drug Administration authorities require that the weight of a standard table produced by the manufacturer should be normally distributed with 350 mg with a standard deviation of 40 mg. Present the required analysis and comment on whether there is significant evidence that the lajak laku tablets produced in December 2021 to follow this distribution. Before we start doing the goodness of fit test, we need to collect our data by creating a frequency table with a suitable range of value. As you can see here, this is our frequency table of weight with 8 categories and grand total, which known as N is 200. First of all, for goodness of fit test, we need to set our hypothesis statement. So, our H now is the data follow normal distribution with mean of 350 mg and standard deviation 40 mg. While HI is data does not follow normal distribution with mean 350 mg and standard deviation 40 mg. The data is the weight of the standard table produced by the manufacturer. Then, we need to find the probability of the normal distribution, which is the P, but let the X represent the weight of the standard table, which has the mean of 350 and standard deviation of 40. Then, we need to convert the X into the Z by standardization. In order to get the probability of the normal distribution, by convert the X to Z, we refer to the statistical table to get the probability of the normal distribution. After we calculate the P bracket X equal to Xi, which are the PZ, we need to find the EI. If the EI is lesser than the 5, we need to combine the category by summing up the OI and EI to the nearest category. Then, we can check our calculation of EI whether it's correct by checking the sum of the value of the OI and EI, which will be the same as our N value, that is 200, and the sum of probability P bracket X equal to Xi is equal to 1. Then, we have to find the chi-square by using the formula of OI minus EI power square divided by EI. In the end, we have 6 categories there, and the chi-square we get is 2.1502. Moving on to the division rule, the level of significance we use alpha is 0.05, the number of row K is 6, followed by the number of estimated parameter is 0. Thus, the degree of freedom we get is 5. Then, we need to calculate the critical point, which is the chi-square alpha K minus C minus 1. By referring to a statistical table, the critical point we get is 11.0705. In general, we need to reject the H now if the chi-square test is greater than the critical point. Lastly, in conclusion, since the chi-square test equal to 2.1502 lesser than the critical point equal to 11.0705, fail to reject H now and hence accept H now. We conclude that the weight of a standard table follows the normal distribution between 350 mg and standard deviation 40 mg. There is significant evidence that lajak laku table produced in December 2021 follow this distribution.
Hello, my name is Guan Xian. I will be presenting the part C, where I will present, analyze, and comment whether there is any significant difference between tablet weight from different shifts. So we are using one-way ANOVA analysis of variance to verify if there is any significant difference between tablet weight from the different shift. This is because this method allows us to compare several groups of observation which are independent but with different means respectively. The hypothesis statement for our case are as follows, whereby the null hypothesis, no significant difference exists between tablet weight from different shift. The alternative hypothesis is the significant difference exists between tablet weight from the different shift, where the mu1 represents from morning shift, mu2 from evening shift, and mu3 from night shift. The data is then analyzed by using the Excel data analysis software tool to calculate one-way ANOVA analysis of variance. Subsequently, we obtain the output summary from Excel. Notice that the mean for the three groups are as well as the count, sum, and variance of each group can be seen in the summary table. F critical in the table below refers to the upper critical value of the F distribution, by default at 5% significance level. So from the table we can see the P value is 0.3917 and the F critical is 3.0418 and the F calculated is 0.9418. So for the decision rule with significance level of 0.05, we will reject the null hypothesis if the F-test is larger than the critical value. So in conclusion, since the F-test 0.9418 is smaller than the F-critical 3.9418 and the p-value is larger than the alpha 0.05, hence we fail to reject the hash knot and we accept the null hypothesis. So we can conclude that there is no any significant difference between the tablet weight from the different shift at significance level alpha equal to 0.05. That's all from part C. Thank you.
Next, for part D, we have regression analysis, prediction of the tensile strength. From the question, it requires us to predict the tensile strength for such tablet at relative density of 68%, 74.3%, and 80.1%. And we have to present the regression analysis and comment on the validity of the model that we have used. From Excel, by using regression analysis model, we will obtain all of this value, and I will explain to you later on. For simple linear regression equation, we get y equal to beta x plus alpha. Alpha is y-intercept, x is independent variable, relative density, beta is gradient of slope of the line, and y is dependent variable, which is tensile strength. The unknown regression coefficient were estimated by Excel data analysis. We will obtain the coefficient for intercept and the relative density. From data analysis, we will obtain the value of alpha and beta, and we will get the linear regression equation y equal to 0.08090x plus 0.01828. For prediction of tensile strength, at 68%, we will get the value of 5.5195. At 64.3%, we will get 6.0292. And at 80.1%, we will get 6.4984. From the data analysis, we will get the value for correlation coefficient. From this value, we can see that it is near to 1. Hence, we can conclude there is a strong positive linear relationship between tensile strength and relative density. Residual plots, we can see that it is randomly scattered around the center line of 0. This means that we get a pretty accurate value. Validity of the model. For relative density line fit plot, we got positive linear regression relationship. This concludes that the linear regression model is a valid model to be used to predict the test result of the tensile strength of the pill from the relative density with up to 95% confidence level. Thank you, that's all from us.